So we're going to factor by grouping, or it's also called the AC method. And we'll start out with a basic trinomial with just x squared plus bx plus c. So factor x squared plus, let's say, minus x minus 6. So if I want to factor this trinomial, we already know what it factors to. We're kind of good at these. So I know that it's going to have to be an x here and an x here to get us an x squared. And it has to multiply to negative 6, but it has to add to become to this negative 1. We know that's going to be a minus 3 and then a plus 2. So we can see that this is going to be plus 2x, this is minus 3x, which is going to add to that minus x. So that is the factor of this. What the AC method asks us to do is it says, figure out what A and C are, and then multiply those together. So this is 1, and this is going to be negative 6. So what AC is equal to 1 times negative 6. So this is going to be equal to negative 6. So what I'm going to do is I'm going to do factors of negative 6, very similar to what we would do in our factored method. So factors of negative 6 would be 1 and negative 6, and then negative 1 and positive 6, and then we're going to have 2 and negative 3, and then minus 2 and positive 3, and then we're going to figure out, the sum of these. And really what I needed to do is I need to sum to become this negative 1. So this is minus 5, this is positive 5, this is minus 1, this is positive 1. So we can see that the correct ones are here. So this is where that factor by grouping comes in. Sometimes you see these polynomials that are 4 terms long, where the center 2 terms are like terms. So it means I can rewrite this x squared minus x minus 6 into 2x minus 3x instead of this negative x. So we're going to have x squared, and this negative x is going to be a plus 2x, and then a minus 3x, and then I still have that negative 6. So here is still negative x. What we're going to do is we're going to factor the first 2 terms, and we're going to factor the second 2 terms, pulling out the greatest common factor of each. And what's nice is we're going to see that, so x squared plus 2x minus 3x minus 6. So if I'm looking at just the very first 2, we can see that these share an x. So I can factor an x out of those. So this is going to be an x, and then this would be left with x plus 2. And over here we can see that these 2 terms will share a negative 3. They share a negative 3. And really the goal here is to get that same binomial of x plus 2 out. So you're trying to factor this out so you get an x plus 2. So if I factor a negative 3 out, this becomes x. Negative 3 out here, this becomes plus 2. So now what we see is a polynomial that really has 2 factors. Like this is a factor because it's all multiplication. This is a factor because it's all multiplication. And they do share a factor. This factor and this factor both share this x plus 2. Which means you can factor out that x plus 2. Factor x plus 2 out of this, this factor here, you're going to get an x back. And you factor the x plus 2 out of this factor, you're going to get that negative 3 back. Which you can see is it's the same factorization that we had before. Now I know you'd ask, well, why would you do the AC method on a trinomial like this? Well, you wouldn't, because we're really good at this. What the AC method is really handy for is for coefficients that are not equal to 1. So let's put some coefficients not equal to 1 and see if you like this method as opposed to the guess and check method that is in the other video. So we'll factor this 3x squared minus 10x minus 8 using the AC method. Now, what we have to do is figure out what A times C is equal to. So A times C is going to be equal to 3 times negative 8, 3 times negative 8, so we get negative 24. So what we're going to have is we're going to have factors of negative 24. And then what I want to do is I want to look at the sum of these factors. So factors of negative 24 are going to be 1 and a minus 24. You're going to have a minus 1 and a positive 24. The beauty of this is in the previous method, you would have to switch the orders of these. But in this case you don't. So we're going to also have a 2 and a negative 12, so then a minus 2 and a positive 12, 3 and negative 3 and a negative 8, minus 3 and a positive 8, 4 and a negative 6, and then a minus 4 and a positive 6. And we're going to check out the sums, and what I need the sum to be is I need it to be negative 10. So, minus 23 was what those led to. 23. This is going to add to a minus 10. This is the one. I'm looking for that minus 10, so it's going to be these. All right, so what I have to do is I have to rewrite this negative 10x into plus 2x minus 12x. So this is going to become 3x squared plus 2x minus 12x minus 8. And the order doesn't matter. If you had a negative 12 and a positive 2, it'll still work out, and I can show you if I remember this example. But order didn't matter. It'll still factor to become the same thing, except your binomials will just be switched. Okay, so this I can see is that negative 10x. These two polynomials are equal. So we're going to factor by grouping, which means I'm going to figure out what the first two share. So let's figure out what these two share. The only thing they share is an x, so I factor an x out. And I'm left with, this is going to be a 3x, factor the x out, and this is going to be a plus 2. Now our goal is to factor out the correct number so that I get another 3x plus 2. I want them to share this binomial. So what do I have to factor out of this negative 12 to produce a positive 3x? Well, negative 4. Negative 12 divided by negative 4 is a positive 3. And I still need an x here, so this is going to be 3x. And then negative 8 divided by negative 4 is going to be positive 2. So I can see that I have that common binomial that they share. So again, really, this is a factor and this is a factor, and these two factors share that 3x plus 2. So what I'm going to do is I'm going to factor out that 3x plus 2 from both of those factors. This factor will yield a x, and this factor will yield a negative 4. And that's how we're going to factor this. AC method people tend to like because it's a lot quicker than just the guess and check method. So we'll do another one up there to make you feel comfortable, and we'll move on. But first, I did say I was going to switch the order of these things. So I'll show you that it won't matter if you're the order that you write these, as long as you find all the possible abilities that'll get you to negative 24 with order not mattering. So we used a positive 2 and a negative 12. What if you did it this way, minus 12x and then a positive 2x minus 8? Is this still going to factor to become the same thing? You'll see it will, but the x plus 4 will come first and the 3x plus 2 binomial will come second. So first, we need to common factor from here. They're going to share a 3 and an x. And I'll be left with x, and negative 12 divided by negative 12x divided by a positive 3x is going to be minus 4. Now I'm trying to get that same binomial factor here. So in order to do that, I'm going to have to factor out a positive 2, and I'm left with that x minus 4. So now you can see that they both share that x minus 4. And I'm left with that 3x plus 2. So the exact same set of binomials, just opposite order as far as multiplication. But multiplication is commutative, so this and this are equal. Those are equal. So finally, you can see where this AC method would shine is this trinomial would be challenging to work with, because if you're going to do the guess and check method, 12x can happen multiple ways. You could have an x and then a 12x. You could have a 2x and a 6x, and you could also have a 3x and a 4x. That there's multiple ways to get that 12x squared. So then you're going to have to put all factors of 10 into here, all factors of 10 into here, all factors of 10 into here, and figure out what one works, which is extremely tedious. So using the AC method, we can get around that and just figure out what A times C is. and see what adds to become that positive 23. So we know that A times C is going to be 12 times 10, which is going to be equal to 120. And then I need to know the sum of these particular numbers. Now I know the list is a little extensive when we're trying to find factors of 120, and you can really just kind of pull out your calculator and say, well, what's 120 divided by 1? So, 1 and 120. I know this has to be a positive 23, so this negative 1 and this negative 120 is going to fail. We're going to have 2 and 60 minus 2 minus 60. Again, the negative numbers will fail. We're going to have 3 and 40 minus 3 minus 40. 4 and 30 minus 4 minus 30. 5 and 24 minus 5 minus 24. And what I'm really looking for is, I know this is 123, the next will be negative. This is 62, this is 43, this is 34, this is 29. We're getting better. I'm trying to find a positive 23 here. So 6 and 20, negative 6, negative 20, but 6 and 20 is 26. So we're getting closer. Actually, looks like we might hit it next time then. So I have 8 and 15, and I can see that, and then negative 8, negative 15. But it's the positive one that's going to yield that positive 23, which is what we're looking for. So rewriting this 23x is going to be 12x squared plus 8x plus 15x plus 10. Again, the order doesn't matter if it's the 15 first and the 8 second. It'll still work out. So these share a 4x. Greatest common factor between the first two, and then just make the other two have that same binomial. So this divided by 4 is going to be 3x plus 2. Now what I'm looking for is a coefficient so that I get a 3x plus 2. So 15 divided by 5 is going to be 3, so this is going to be a plus 5. And this will give me a 3x, and divide that, it's going to give me a 2. Divided by 5 is 2. And they share that 3x plus 2. Factor out to 3x plus 2, and I'm left with that 4x plus 5. Which would be a lot faster than that guess and check method, especially with a that has multiple factors. That's it.